Well, similar problems to what I had with my phone. Now I'm using a camera. Thought it was on, it wasn't on, so you missed the cut. I took 20 thousandths off the end, cleaned up really nice, 700 RPM. Nothing's changed from the first shaft, so I just put this back as my stop, so I get the same results. Rose indexer is in place. So just make it square and then lock it down. Tighten up the workpiece in both vices. Seat the part. Okay, so then double check the rose index. So you can check from this way, and you can back it with this is a white Teflon, which is real good because if it gets dirty, just wipe it off. Makes a good background. Good on the grinder. Another thing I'd mentioned on the segment that didn't get recorded, with all the cranking, kind of wears on your hands, even my hands, and just using a rag over in your hand on the handle works pretty well. So I'm setting the knee at 0 right now. I don't do anything fancy for touch-outs on this stuff. I just lightly touch the tool to the workpiece. Even on carbide I do that. Don't slam it so you chip your cutter. And I had already taken notes. I want 290 thousandths off every flat, and that'll give me my end result. So, quill is locked. We don't change it at all. We lower the table. We move the cutter away from the workpiece. Now we crank the table up 290 thousandths. 1 revolution, 2 revolutions, and almost a third, so 290 thousandths. That's it. That's all I'm doing. And we're going to take all that off. Full depth. RPM on these cuts I liked around 650. Another great thing about this head is it's a variable electronic, so I can just a little touch of the dial. Okay, so our cut in is 175 or 1 inch 750 thou. So I'm taking on the conventional cut, I'm doing 100 thou. So 1 inch 650, make a pass. Okay, now 250, so down to 600 and then 400. And you'll see this cutter with that RPM is quite nicely. Great chip action. Lots of heat in those chips, no heat in the part. Okay, so now 100 thou off that, 300. I can do more on the back, or on the conventional cut. It's a little more work for myself and the machine. So, we'll just keep it at that. And I'm going to take a whole 300, get a nice even number, see how 300 does. Speed up this process a little bit. There's a 300 cut. Again, beautiful chip action. All the heat going out in those chips. Another 100. Actually, that was 200. Don't get carried away that direction, doesn't like it. Okay, so we'll do another 3 since that went so well. Back. Another 300. Another 100. And the final cut, which puts the DRO at 0. I lock the table for that. And again, when I lock this table, the table moves half a thou. Okay, and this one I just go a touch slower. Now I'm just moving the cutter out of the way for the rotation, so I have to worry about hitting the cutter, and I need the room to clear the chips out of the vise. Whoops. I forgot we moved the table back. Had a little conflict over here. This already had holes in the machine to put something like this on here. I didn't want to Swiss cheese the machine. It's great when you're working real tight and everything's real close, but you do have to worry about those obstructions. Let's see how that did. That's why it's called Everything's a Project. All this work is very tedious. It can wear you out, especially doing stuff on a budget or just trying to get the shop set up like I am right now. Got everything compact in a small garage. Anyways, everything works out pretty good. Learn each time. Okay, so now we're going to loosen the vices. Keep my hand on the material. Raise this up so I can clear the chips. Actually, wipe off the part first. Be careful around the sharp edges of the cut. And just brush out the chips. I don't like to use a lot of compressed air. One, it puts the chips into crevices that shouldn't. And then also, it's the noisiest thing I have in my shop, even though it's a California air. And again, it also takes energy. I kind of keep an eye on energy. I'm not a big green person, but reduce, reuse, recycle, improve. No reason to pay for stuff I don't need to. No reason to waste it. Again, we're up against the stop. I made the rotation. I used the square on the rose indexer. We'll double check, quadruple check. I can see daylight. That's another nice thing about this light. The backlights are really good. Again, keeping your hand on the part the whole time. One, to keep it in position. Two, to keep it from popping up. And it's settling little off. So like right now it looks good. Let's see how it goes again when I tighten it. Okay, that's good. Well, see if we can look in there. So right now there's no daylight. There's a worn edge. Well, the light picks up on the edge, and so you'll see that, but there's no light between the square and the indexer. Come back over here. Actually, we'll change the angle a little bit for this cut. Okay, so that's good. Tighten this place. Bring the cutter back over to 1 inch 650. Now if we were doing just the one end, there's a whole bunch of other methods that you could use. The reason for the rose indexer is because you have to know where this end is compared to the other end that's 5 feet away. If we were doing just this one end, you could use a square on your previously cut flat. If it was, say you were doing just 2 flats, like for just a simple wrenching, I've used gauge blocks stacked up, and then when I'm square to those gauge blocks, I know the opposite side is square to the first cut. Okay, so you guys have already seen this, so we'll come back in a little while.